It's time. All right. I am Kelly Heller. I'm going to make a sales pitch for Go. It's definitely on the sales pitch side, so I certainly have demerits for Go in my head, and some of you will be able to guess what they are once you know a little bit more about my background, but you can ask me about those at the end if you want. If there's no other questions, somebody raise your hand and say, what's bad about Go? So I don't want to say really anything about myself except what's relevant to this talk, and probably two most relevant things are I love to write code. It's more than a love, it's frankly an addiction, and I get paid for it though, so it's left untreated. And the other thing relevant to this here and now is I love Linux, I love open source, and I love SCaLE. I found these in my closet. I put one on this laptop. This laptop is not 8 years old or however many years, but these are SCaLE 10x stickers. I have been attending since SCaLE 7x. So yeah, I love SCaLE. Yeah. Oh, and this is from Linux Chicks from last year. Thank you, Linux Chicks, for this. My bling. Okay. So my authentic Go story is that I approached it with heavy skepticism. I was a skeptic, and I was a very specific kind of skeptic. I was the grumpy, curmudgeon-y, grumpy coder, graybeard, battle-weary skeptic. And of course, that has nothing to do with Go. That is only a function of years in the industry. My native language is C++. My husband asked, are you explaining the boat? I didn't know if it would need explanation. It's just C++ is gigantic. It's an ocean liner of a language. And so, you know, when you have a language and you've been successful with it for a while, two things happen. You see a bunch of fads come and go, and then when they go, you think, oh, yeah, I'm so glad I didn't jump on that bandwagon. I'm fine. I was vindicated for staying put. And, you know, you just get really good at the thing you're doing. And with something like C++, you're never lacking for the language feature that you could think of. So you're just good. And you build up a whole bunch of tricks, idioms, design patterns, and you don't want to lose them, and you shouldn't, because that was a big investment. So when I look at other languages, I don't really care about aesthetics. This is, you know, C++ rip here, sorry. I'm immune, I'm completely inoculated, so none of my sales pitch is about how Go looks or anything like that, or how it feels, or, oh, look, you can read it like an English sentence, or I don't care. Oh, and one other minor point here while I'm hopefully moving off of the topic of C++. When you're brought up in C++, there's another thing you know about, and that is language lawyers. So if I have language lawyers here, and it's good, because it teaches you to be very precise about what you're going to say. So in the interest of precision, and I nod to the lawyers out there, I'm going to say things like, in Go, you can do this, or Go comes with feature X, and Go lets you do this. Usually I mean the language, the actual language, independent of whether or not you would maybe go out and write your own compiler for the language, or your own, you know, runtime, I guess, for the language. But sometimes I do mean the entire tool chain. And right now, there kind of is one tool chain that when you get the Go distribution, you get Go, the compiler, Go build, And there's a linker in there too, but there's, as far as I know, you never type go link, but you get go build, you get go doc, you get go test, you get go format. And so, yeah, for the language lawyers out there, when I say, yay, Go gives me this feature, usually I mean the language, but sometimes I mean the tools, and so there I said it, don't call me on it. Okay, so I said I don't care about really the aesthetic look and feel of the language. Where my head likes to live, I really like to think of my projects at a zoom out level. Any individual file could look ugly or pretty, but I care about, you know, across all the files that I have, some of them are hopefully, you know, part of a sub-library, and then there's sort of higher level library on top of that, and then the libraries start to group together, and at the very end you have some executable layer that hopefully just initializes a few things from your libraries and starts some loop, and there you go. So really what I'm looking for is, you know, if you're kind of trying to tell me like, hey, don't use C++ anymore, use Go, or don't use C++, use Haskell or Rust or whatever. What I really want to know is, what are you going to do for me to make sure that I'm not on the left side of this and that I can control being on the right side diagram? And what I always say, if people ask me, why on earth do you still like C++? My answer is, if I think of a design, I can express it, and I can enforce it. And that's what I look for, because I think a lot of languages, you can start with this. Like, I know how to start with this in Python, but I don't know how to enforce it. I don't know how to say, oh yeah, you know, clone me, fork me on GitHub, and then submit a bunch of PRs and then not have it look like this, because I can't do all the tricks I know to just stop somebody dead in their tracks, like it won't even compile if they try and start adding bidirectional dependencies and stuff like that. Anyway, so this is what I look for. So after I fell in love with Go, and I wouldn't shut up about it, and I told all my friends, and they're like, somebody said, you should give a talk, so that's how I got here. I started thinking, well, why? You know, why me, the skeptic? Why am I in love with Go? And Go is kind of opinionated, and I tend to not like opinionated things, but it just feels like they made all the same opinions I would have had, so it feels good for that reason. And all of these tricks that I've been talking about, they're still there. And so here's where, you know, I don't know. Do I have C++ buddies in the room? Anyone? Woo! Okay, cool. But not the majority, probably like, what, 5%? But so for the rest of you, here's where maybe if you look at this list and think, do you see your favorite things on here? Maybe you like some of these things too. Or if not, maybe think in your head, what's your wish list? Like whatever your language is that you like, if it's Ruby, if it's PHP, if it's C, whatever, why? Because that's what I tried to do after I liked Go. I was like, how can I reverse engineer and articulate why it still, you know, fed all my needs? So I do not like to compromise on multi-paradigm, and yes, I do functional programming in C++. If that sounds shocking, get modern C++. We have lambdas, it's awesome. We have a networking library, ASIO, that's very functional style. But you know, some things, you just want to function, Java. And so, you know, I want that in the language. I want to just write a procedure, and then I also, you know, use some tried and true, like classic Gang of 4 design patterns. So I don't like to compromise on those. Type safety. I feel like type safety has been winning lately, but that's my opinion, I guess. And then data hiding, and that could be with or without, you know, compiler type checking. Data hiding, just that ability, sort of what I was talking about before. If I have something in C1 and I don't want anything from A2 to be able to talk to it, like, what do? Can I mark it private to a module, private to a class, just various mechanisms for reducing all those arrows in the diagram and then making sure they stay gone. So then if you like these two slides, the logical next question is, oh, let's have a step-by-step. And that was sort of my question, but I failed. That grossly overflows the bounds of this talk. I would love to talk about each one of these, exactly how they can help you. But I decided, since I can't do that, pause. Everybody go. We'll do 3 years of study and experimentation. And then, okay, now we've all got it. So these are the things I care about, and yay! Go has all of my power tools that I care about. Oh, and I forgot to mention, we're almost done with the intro. Sorry, I might have gone a little bit long. But this talk has 3 parts. It has the lighthearted intro that's also fairly light on content, and we're about done with that. And then it has a Act 2, which is Go Giveth. This will be Act 2. And so I just hope to put up a bunch of code and just show and convince you that Go has these things, because I don't want you to have to take my word for it. And I don't want you to go home and be like, exercise for the reader. Like, I hope to show you. And then Act 3, which is the conclusion, is Go taketh away. And this gets back to that opinionated part. There's definitely things that Go doesn't have, some of which are really interesting decisions. And it's that's almost the main linchpin of why I was so excited. It's like, when you tell me Go has these things, I go, well, okay, cool, but I already have these things already. But then when I learned about the things Go doesn't have, it suddenly became really like, oh, I have to have this language now. I have to have it. And so here's why. Probably, I'm going to guess everybody in here does programming. I'm sure I could even come up with some obscure definition of how, like, writing a certain kind of email, or I guess using a spreadsheet is like programming. So I'm going to say everybody in this room is a programmer. I don't care what your title is, if you're a manager or QA or whatever. As a programmer, oh, wait. So this is the crowd participation part. Okay. Without harming any laptops, secure your laptops, raise both hands. A little higher. Okay, that was just to stretch. Okay, sorry. Okay. Oh, good, I got a clap. My husband said people would leave after that. I'm somewhere in between. I just figured nobody's going to raise their hand again now. But, okay, so last question, and this one's for real. As a programmer, raise your show of hands, have you ever had an argument about a programming language? Or, right? And I'm going to say, so that was the whole room, speaking to the video there. And if anybody didn't raise their hand, it was just because I tricked them earlier and they were taking their revenge. Okay, so that's why what Go doesn't have is so exciting and so refreshing. I've had so many arguments, so my big ones that I've had to sort of belabor the point over and over again with training juniors or just recalcitrant seniors or what have you is, you know, when are you abusing exceptions, or when is it the proper use of exceptions? Why is composition really, you know, if you can do composition over inheritance, why should you? White space and all that stuff, I hate that. I just hate it. I don't care. I will put my brace wherever. I don't care. Function overloading, compiler warnings, which if you don't come from a compiled language, that one doesn't pertain to you. But it's like, oh, you know, the compiler is warning about this line of code. Yeah, it's fine. Just leave it there or whatever. And then others are like, no, you have to fix the warning. And then you get a different set of warnings on one system than on the other, or one version of the compiler than the other, all these things. So that is, pretty much the end of section 1. In retrospect, I realize I shouldn't have been surprised of any of this, really. And that's because where did this language come from? I am just so, you know, we're at a Linux conference, so, you know, we're not worthy. And I'm so glad, you know, just like when Linus, you know, you thought, what, Linus doesn't owe us anything. We have Linux, and then we got Git, and it was just amazing. This same thing, it's like Ken Thompson, his handle is Ken. He's the Ken. He got a 3-letter handle before any of us were born, and right? Before any of us were born. Just own it. And also the book, which this is an amazing book. You recognize this name right here, this book author. So, and this is the book that basically convinced me that I'm in love with Go. And so none of this should really be a surprise. And this slide alone is probably a good pitch for why Go. Okay, so I was going to use the Go playground, but then the network was being weird. So I have it all locally, so I'm using Emacs, oops, which I didn't launch yet. So, sorry, I should have had this one up already. Oh, why can't I, come on, taskbar, go away. Well, let me just run this. This is, okay. Why is my taskbar there? And yeah, sorry, I'm on Windows. This computer has VGA, so that's why I brought it. Can I move my taskbar then? It's supposed to be auto-hiding. Bottom. Left. Oh, now it's still not auto. Sorry, guys. So somebody said unlock it, but I don't know. Well, that would help me drag it, right? But then it still wouldn't. It was cooperating before, but maybe it's weird because I'm plugged into the network or the video cable. Okay, anyway, as long as, no. Oh, why can't I? Oops. Oh, now where's my compilation buffer? Shoot, maybe we will use the playground. Okay, let's try one more time. Yikes. Okay, well, let's see if the playground will work then. Sorry about that. Thank you for your patience. All right. Okay. So, the code on these slides, it's mainly in the slides for the sake of if you wanted to look at the slides after the fact, because I think it's a little hard to read. So in the playground, which I should then be able to make it bigger, is this, can people read this code? Is it pretty dark? Try dark. Yeah? Okay. Shout out to, this is actually a Chrome extension called Better Go Playground. Otherwise, it wouldn't have that dark option. So thank you, Better Go Playground. Okay, so here we go. This is just to see any old kind of Go code on the screen. So here you go. This, can I run this already? I should be able to run this. Okay, so we declared some Boolean. We're printing it. There you go. This is, again, just entirely meant as warm-up, just so you can have it in your system. What does Go look like at all if you haven't seen it? Yeah, okay, so good question. Oh, and by the way, yes, through this whole part of me trying to live code and not stub my toe, questions. And if I don't see your hand, yell question or whatever. So this is the short assignment. And so we are doing static types, so that is definitely a Boolean, and I can't assign anything else to it. It is, you know, doing type deduction. I hope that's the right word. Who's the language lawyer? If you want to be explicit, so here's the way that you could make it explicit, and what it's going to look like is the type comes after, and I know you were watching the Rust talk too. Same as Rust, as I now know as of today. You put the type after the name. So, and then you don't use this the short assignment operator or the short definition or whatever it's called. Then you would go like this, and that. Okay. So this is just, you know, creating data, creating some local variables. So a function, again, also very familiar from pretty much every other language I know. So keyword func, and then you give your function a name, and then you have an arbitrary list of arguments. Again, the name of it is text, type is string, and then the return type of your function right here. Or if it doesn't, if it's essentially void, you could just leave that out. So now we have this function. It's using something from the strings package, which gives me a chance to point out that another thing that I know everybody likes to look for in a language, as it should be, is what kind of batteries come included. And Go has a lot of batteries included. There was a talk Thursday. Are the Procore people in here? Somebody did the talk with Postgres using Go, and they also mentioned that all the libraries were ready to go. There was a Postgres connector, and they were doing something that required cryptography. There was a cryptography library that was already there. The standard libraries are great, and they are heavily cross-platform, and it's also, they make it very easy. There's a registry of third-party packages available that's also great. But even just what comes with the language distribution is phenomenal for HTTP, for JSON, and it has its own proprietary marshalling to Go streaming if you want something faster than serialized to JSON. A lot of stuff built in. Okay, so the function, hopefully that doesn't really look surprising either. We're taking text, trimming off any white space from either end, and then if we didn't get an empty string, then at that point we're saying this string has content. The only reason I wrote that function is because I wanted to do one other thing, which is your most common collection type that you would use is a slice. And really, so there's also such a thing as an array, and the difference is that the array would be a raw array, contiguous memory, and you would give it a size, and then it's not resizable. A slice will create an array under the hood, and then your slice is a pointer to the underlying, now sort of opaque from you, array and a length. And it can be dynamically appended to, and then of course it internally will resize or create a new array and copy things over, and anyway. So this is a slice of strings, and then I'll do just for loop. Let me not mess up. Where are my notes? Okay. To iterate over this slice, range of lines. Okay. We'll just do it like this for now. And yes, I'm using println. There's printf with your typical formatter strings, and even some cool ones that automatically quote for you, so that you're not doing weird stuff like slash quote all the time. I don't know, maybe other languages have that, but let's see. Print. fat finger anything. Oh, I didn't mean to print the line. I meant to print call the function. But this is all straightforward. Okay. Okay, so that was just so that everybody could see what Go looks like if you haven't seen it before. Now, please. Oh, no. Okay, I'll open it in a new tab. Okay, type safety. Let me just talk about this one. Sorry. The internet said that it was more fun to watch somebody write code than to read it on a slide, but maybe they didn't meet me. I don't know. Okay. So what I was attempting to show right here, probably everybody knows how type safety works, but just to, again, sort of get warmed up and see it in Go. So we work for a veterinary office, and when we ever send an email or print out a web page welcoming the user, we're welcoming Mary, and we decided to be super cute and like inclusive of our actual veterinary patient who is Mary's dog. And so if Mary has a dog, then it's saying it's going to print out to Mary and dog. Yeah, I know that's not great. It should say like and her dog, but then you're going to ask me to like internationalize it too, and that's just not going to happen. So then you want to rewrite the function and realize, oh, well, some people have more than one dog. So instead, we're going to write it to take an integer. And if there's greater than 0 dogs, then we're going to write the salutation as to Mary and 3 dogs, or however many dogs. And so I actually, to make sure I was being honest, I did this in Python also. And in fact, if you write this second version and then you paste it over your existing one so that it's still salutation, Python, it's not compiled, it's not as strong typed. It will still let you make this call, and then it'll print out to Mary and true dogs. And so I know this is like a little contrived, but at the same time, I feel like we've all gotten that email to like Mr. Null or Mr. and Ms. Null or something, and this is kind of along those lines. Okay, so Go has type safety. Functional programming. Let's see, can I actually open this? So if you do functional programming, I consider this sort of hello world. It won't be shocking at all. If you don't do functional programming, this looks very strange, like the first time you see recursion and you think, that can't work. So this is what it looks like in Go. We have, as before, keyword function. We're defining a function. Now there are no arguments. And now this whole remaining bit is the return type. So we have a function that takes 0 arguments, and it returns a function. Yeah, and when you have the function that is returned, you can call it with 0 arguments and get an int. So this is a closure. The closure will, actually, I like this better with -1. The closure, when this inner unnamed function is constructed and returned, it will capture counter value at -1, and then that becomes part of the closure. So here we're going to call it, and so you can maybe, oops, don't do that. Counter. Expect or not expect what is about to happen. What did I do? Okay. And we'll run it. And so there we go. So yay, functional programming. I don't know why you would ever write this one, but I do have a better example that I have used in real life and found it to be quite elegant. If you imagine that make counter is actually, we'll call it make file iterator, and inside there you initialize a file handle to an open file, and then every time you call your iterator, or whatever you want to call it, you get another line back from the file that was open, and then you can actually do something close to RAII, that was for like the 3 C++ people, where inside of the closure, when it gets to the last line of the file, it will close the file, and so it's very clean. The user code ends up looking very much like this, where you just say, you know, make my file, line it or whatever, and then when you finally get it returns null or whatever, you just stop caring about your iterator and you're done. So let's see. I will skip over this other thing, but it's pretty cool if you're ever looking back over the slides. This is another example of using a closure here to sort of encapsulate a map. And so that's an immutability trick. It was from Stack Overflow, so there's the link. Okay, so Go has type safety, Go has functional programming, Go has object-oriented programming. It's super important, but this is like the longest, most painful example. So let's just see. All right. Okay. So this is what making your own type in Go looks like. You'll notice that the keyword is struct. It's not class. That's all you get. It's struct. So that's cool. Again, that's sort of the opinionated thing if you're used to C or C++ and you can declare it as a struct or a class. And what's the difference? Well, some certain default syntax, and otherwise nobody knows, except the Visual Studio compiler is weird about it. And so, it's just struct. So this is a class definition. And I have chosen to abstract a classroom. And all my classroom does is it's basically a container for desks, and so we have a count of how many desks are in the classroom. So let me just say some interesting things about objects in Go. Right here, the fact that this is a lowercase d means that it's a private data member. I thought that was pretty cool. I've since talked to people that find that obnoxious and not obvious enough. But, you know, and I wondered about that. Thank you. This man just said there are languages and alphabets in the world that don't have the notion of uppercase. Thank you. Cyrillic, I believe, is one of them, or at least I was told by a Russian coworker that they have upper and lower, but in newspapers or in some contexts they don't use it. And so I was sort of teasing myself that same way, because you can write your code file as UTF-8 encoded, so you could write a Cyrillic Go program, and then I don't know what happens. Is everything public? Is everything private? I don't know. Does anybody know? Has anyone done that? Anyway. So yeah, so that's how you toggle basically public and private. Other argument you never have to have again is, why is protected visibility evil? There's no protected visibility here, but there's also no implementation inheritance, so it's a moot point. Okay, so then if you want to add a method, so we're going to instantiate a classroom and we're going to call add1desk. Your instincts are, if you're from Java or C++, to try and add the method somewhere up in here in the body, and that's not how it looks in Go. So how it does look is right here. It's the same function syntax as before, but then you add something that they call a receiver, and it's essentially this, or self. The Go people don't like for you to say that. And I don't exactly know why. I read the explanation. They want to emphasize that it's more about writing a function on a receiver than having a this. I don't know. It was kind of lost on me. But so, and they also don't like it if you name it that. So that's, but anyway, old habits die hard, I guess. So this is now, by having a classroom receiver, now we have a method that you would call in the expected way down here. Okay. So there is a lot to say about how Go does object orientation, and I don't know how much people have the stomach to listen to me blather or struggle through the code, but let's just do another example anyway. Does anybody have any questions so far on this one? That's actually kind of nice. It's funny, because even now, 10 years in with C++, I forget to do this. And I hadn't even noticed that you don't. Yeah, again, similar to in the Rust talk, or no, I misunderstood her, never mind. Nothing about semicolons in Rust. Semicolons exist in Go, but only in, and you can type them in certain places and the code will still run. Yeah. Thank you, like the for loop. And even here, like I just added that one and it was okay, and I can add one right here and that's okay. But two things about it. You rarely need them, and the one case this gentleman pointed out in a for loop, when you have your initialization and your test and your increment statements, those you still need the semicolon to know where one ends and the next one begins. So you rarely need them, and then in the other case right here, if I click this big format button, they will go away, or they should. Let me see, they went away, and I'm going to talk about Go format. So basically, since Go format took them away, you should feel bad. I don't know. They weren't necessary. That's not the official format. Okay, yes. So I guess we do have an appetite for this. So how would you do inheritance? Well, I also mentioned, yeah, no protected data. There's public members of a class and there are private members, but no protected. What happens if I want polymorphism? Let's see. Tell me what you said first. I want to use your words too, though, and then you said, how do you do inheritance? Inheritance or extending a base class, right? Okay, so again, arguments you never have to have if you're coming from C++ or Java. So the reason why I wanted to change the word to polymorphism is you're basically correctly stating that there's two kinds of inheritance. There's interface inheritance, and then the extend, which I always taught myself in Java that when I see extend, that means bloat. Extend, which is implementation inheritance, not interface inheritance. So in Go, you can have interface inheritance, and then they have this new concept, sort of, that they call struct embedding, which is so fun. And this is where, and I mean that because I just love the idea of not having to fight people about composition versus inheritance. Struct embedding, and I'll try and do one up here fairly painlessly, I hope. Struct embedding is composition, but they have so successfully disguised it that you will find multiple blog posts in the world explaining that this is how you do inheritance in Go. And it's composition. But I consider that like a huge win, that they've sold it, or they've tricked so many people into being like, yay, I can still do implementation inheritance. Yeah, what's your question? Sorry, you know what? I meant to say also when I mentioned the language lawyers and that type of thing that I am not covering Go routines and concurrency because, and sorry, if like half the room wants to leave, you can, I won't be upset. Okay, well, I might have some information for you at the end on the resources slide. But basically, there's an abundance of information out there on that, and I sort of wanted to... None of that was what convinced me that I needed Go, so I'm just speaking from the parts that I like. And but there are great talks, particularly by Rob Pike, one of the creators. Okay. Yeah. I will say a few remarks about that at the end. Okay. But yeah, I'm coming more from a comparative languages sort of tactic here. So back to this man's question in the front about interface polymorphism. So if I want to also say that I have an office and it also has desks. Oh, I probably should have corrected a bug in this first. Let's go back and do that. Oops. So you may have noticed when I was running this earlier, and we had a desk, and I figured this default printing was good enough to get the point across. We had a desk. It was initializing desk count to true when we instantiated the classroom. And we printed it, and you can kind of tell roughly that that was a desk with a desk count of 2 inside it. And then we called add one desk, and then printed again, and it still says 2. So something about my plus plus desk count didn't work. So, and that's why I had this comment here, this needs refinement. You can have a method on the objects of your type, and if it takes the receiver by copy, then nothing happens to your actual receiver. So we need to take this by pointer, and now it works. And so there's a lot of subtle differences here, just like off by one character, so to speak. I already talked about how the lowercase versus uppercase toggles public and private. Now you can have a method, both called the same. You notice I did not change, all I changed was that one character. I did not change the call site. But the receiver type will either be passed by pointer or passed by copy of the object, and that will basically decide whether this method, let me put it this way. If all the methods on your class look like this without the pointer, you have an immutable type, which I think is very powerful and nice to know that that's possible. But in this particular case, we're intentionally trying to mutate this. Question? Yes. The GoBot people. You should talk to the GoBot booth. They have Go running on Arduinos and so forth. Go compiles to machine code on a number of architectures. It compiles fast, and it compiles into a binary that executes fast. But the only sort of remaining hiccup criticism that people would have, adoption issue, is that it is garbage collected. So you can have a GC pause. And I am not an expert on the details of that. Okay, so now we fixed the bugs. So now back to the polymorphism. So now we have an office which has the same interface. So I have a classroom that I can instantiate and add desks to, and I have a office that I can instantiate and add desks to. I better give that a different name. Room 2 is an office. Room 2. Sorry, anybody sitting here going, I could type way faster than her, you probably could. Okay. So these share an interface. So if I want to make a function just a function now, we're not worried about methods. I just have some other code, whatever, some other code that needs to operate on a desk holder, let's just say, right? Anything that holds a desk. Then I'm going to write a function that operates on a desk holder, and we don't know what a desk holder is yet. That's the punchline. But this is what I want it to look like. So when I operate on the desk holder, I'm going to add one desk. And I want to be able to call this function with either. So operate desk holder, I should have made that briefer, and I could pass in the classroom, or, sorry, I don't have my Emacs keyboard now, so I'm like, I don't know any shortcuts to make this go. Okay. So how would I do this? And so this, I can make an interface. Type desk holder interface. So when we declared a struct up here, the only rows of code that you're going to see in between the struct open bracket and struct close bracket is going to be data members. Because as we saw, you put the methods elsewhere. It's the opposite when you declare an interface. The only thing you're going to see are method signatures. So what we're trying to capture here is any type that is capable of me invoking add one desk on an instance of that type. Okay, I think this is all lined up to where I can run it. Okay, yes, and I didn't call any printfs or anything. I guess I could at least put one here to show that we entered this in operation. So I was able to successfully pass both a classroom into this polymorphic code and an office into the polymorphic code. And so this is the interesting part about this, and this starts to segue into controversial items about Go, which is I declared this interface, and so we know what we can expect inside of operate on desk holder. I did not have to go back and make it explicit, any intent, explicit intent to say that classroom is a desk holder and that office is a desk holder. On my theme of not having to argue with people, you can't say that classroom is a desk holder. You can't, there's no way to tag that onto here. I do miss the explicitness, but this means that nobody can abuse inheritance in really weird ways, where I've seen code bases where every object, subclasses, let's say you work at Acme Corp, every object subclasses official Acme Corp object for no reason that I can tell, and they're never manipulated via a pointer to that base type. And I go around asking, why do all these things implement that? And people say, well, because it is an Acme Corp object. But if none of the calling code treats it as such, that's so beyond irrelevant. Okay. Yes? Yes. Yes, because again, type safety. So let's go ahead and change it so that Office doesn't, and let's just see what happens. Yeah, add one desk. Thank you. No, awesome. Thank you. Okay, so I went over on my code demo, sorry. And now there's one other thing, and this, unfortunately, I am just going to have to leave it as sort of exercise for the reader. but we talked about, can you do implementation inheritance? And what you do, because you'll notice there's still duplication here that's probably bothering some people, is that essentially Office and Classroom both have desk count. Office and Classroom both have this call to desk count plus plus, so don't we want to bump that out into a base class? No, but you do want to bump it out into something. And so that's where Go has struct embedding, which I'm not going to demo right now. I'm sorry, I took too long, and yeah, mea culpa. But it's really, like I say, it's awesome because you can't have implementation inheritance, but people think you can, so it's good. So you have everybody's happy. Some are happy in their ignorance, and some are happy in their wisdom. But let's see. So, testing. Yikes. It gives you some awesome built-in testing. You do not, if you get the Go distribution, you don't have to decide, am I using JUnit, am I using CPP unit, am I using Google Test, am I using NUnit, whatever C# has, maybe I already said it. It comes with testing built in, and not only that, but they've, again, testament to these guys have seen some stuff. They put in things that are really important to a large, cooperating production team, which is, so here's how you would just have a test function. You could have a file of code filled with these that take this built-in testing type, which is really just how you output your pass and fail and all of that. That's just, you can write a test, yay. But the other really cool thing, two extra cool things are, we had add one desk. Go test will know, and Go doc will know, that if you have a test, and you name it after a method or a function that's in that same package, and you just add the word example to the front, then this becomes living documentation, because every time you run your test suite, it makes sure that this compiles. And if you add this output comment, it will also verify that the output is still this, so you have sort of a pass-fail. And then when you run Go doc, which is akin to Java doc, it will pull out this code in a nice little example snippet that people can learn your code base and just copy and paste your example code, and you know that it's not stale because it was part of your test suite. I think that's really fun and compelling that that was built in. Also, benchmark. It does some really neat stuff where if you just put benchmark on the front of your test, then when you run the test suite, you actually have to tell it the benchmark flag because it's going to make the test take a little bit longer to run, hopefully not much. It will run all the benchmarks and do really interesting things where it will call the function over and over and over and take an average, and it's going to sort of adjust on the fly based on how long it's taking to run your function, whether it thinks it has time to run it 1,000,000 times and take the average, or just maybe 100, but it'll do like best effort. And so you will, right from the start, have baked in performance testing, which I think is amazing, because it's one of the 97 things that all architects should know, that you should test performance from the get-go. Okay. Oh, I missed my opportunity for a joke. Go format. Once upon a time, there was a language that tried to legislate white space as part of the language. It's called Python. It's not around anymore. And when I learned about that, I was very optimistic about that. I thought, what a cool opportunity to really just stop these stupid arguments. Just make it part of the language and be done with it. And that's what I thought, and go Python. And then, ouch, quit it. And this still happens to me pretty much every time I download Python, like quick and dirty on the fly, and open it in some random editor. This happens like every time. So what Go got right, in my opinion, is that it does sort of legislate formatting, but it's just by convention, and your code will run, as opposed to this. Your code will run if it's badly formatted, but everybody, because I guess we've all been scarred enough by now, we know to take our medicine and you just run Go format and it's built into every IDE for Go and it's not a problem and everybody lived happily ever after. And it has an extra flag, Go format simplify, where it helps you. It does other cool things, which I think are really clever and neat. It'll just catch sort of extra verbosity that you may have typed in and remove that too. Compiler warnings are not a thing. Everything's a compiler error. I tried really hard. I thought, even though I read the words, there are no compiler warnings, I thought, there's got to be something. There's got to be one little thing. And I tried a bunch of wacky things, and I couldn't find any. And as by all authoritative writing, there are none, but I just couldn't believe it. So the one that happens a lot, though, is obnoxious at first. If you have a variable that you don't use, this won't compile, and it'll tell you declared but not used, or something along those lines. I hated that at first, because I do, especially since the Go compiler is fast, you can iterate fast, and so you might be sort of just stream of consciousness, and I need X, because I know I'm going to do this thing with X, but you're like, let me run this, and then it won't get past the compiler, so then you comment it out just so you can do a build cycle, and it gets a little weird, but then, I don't know, at least in my case, I just sort of adapted my habits, I guess, because I learned to love it because it saves you from this one. If you're using the short type deduction assignment, that actually creates result, so then sometimes it's quite easy, and your eyes don't see this bug, where you think you're flipping result to false and returning it, but this will be a compiler error, because you're actually creating result again in this inner scope, and it's just shadowing. So I learned to love that one as a compiler error. But here are others that, and you can see them yourself in the Go Playground if you want. If you click the Go Playground link later and just click run, all these lines will turn red. It's so much fun. And if you're coming from C or C++, you're probably used to these being warnings, except for the top one, of course. And the top one, it's very interesting. If you think of these as pound includes for other header dependencies, it's a compiler error to essentially pound include something and then not use it. But that's part of how they got compilation to be so fast, and it is amazingly fast. You'd have to find the talk by Rob Pike or one of the others where they talk about compiling billions of lines at Google or whatever, and it compiles in seconds. And so that's part of that. And that's also really cool, because you end up with this weird cruft in your C++ programs where people can never remember as they're deleting the code to delete the pound includes, and then anyway. There's no exceptions. I won't even ask for any show of hands, because this one's a holy war, right? But I thought, I don't want to incite like exception versus non-exception battle in here. This is Go defending itself on this note. Errors are an important part of a package's API, and failure is just one of several expected behaviors. Oops, I went the wrong way. And expected, I really like that idea. I think it's kind of an ideal, but if they succeed, if this is the outcome, if people learn to just treat an error coming out of your function as one of failure is an expected behavior, I think that's pretty cool, because I have definitely spent a lot of my time in code reviews telling people, did you know this thing you called can return an error? And you better say no, because you're not checking for it. So you have to. So this is just idiomatic Go. I pulled out some, again, giving you an idea of the richness of built-in libraries. This is the time zone library, the email, I guess, library. I just kind of grepped for things that returned errors. and OS user library. And so this is the pattern. So what Go gives you instead, which is still better than your old school C of return an error code, is you have multiple return values. So the convention in Go is you return a result and an error, and then there'll be a lot of checking, and there's a semicolon, of error not equal to nil, meaning that the call succeeded. And I think I'm already probably over time, so I won't say too much more about that. Again, I touched on, for testing, they have some really cool built-in Go test, and you don't need your JUnit, your Google test, your NUnit. Another thing you don't need is a mocking library, and that makes me really happy. And this actually touches on that struct embedding. And what this is showing, just briefly, and this is like my last little Go taketh away, and then we're done. What this is showing is, so if you imagine that this is a test function, and it's not, because in Go Playground you can't run tests, but imagine that this is some code that you're testing, and this is somehow part of a test suite. You have a function that takes a type OS file info, and so you want to exercise this code without having to instantiate an OS file info, so you essentially want to mock, and you want to mock an OS file info. So what you can already do in the language itself, no mocking library added on, is you can essentially make a fake type, and you plop this name of the real type inside it. And this is that thing that I was saying is called struct embedding, which people also refer to as sort of inheritance. And so now this guy is eligible to be treated as the file info, and you only have to implement the method that you want to quote-unquote mock. And this is a little hand-wavy here, but you can run it in Go Playground and it will work, and hopefully you'll be really excited about that. One thing that crossed my mind, and so then again, go to Go Playground and try it yourself, is, oh, well, all I implemented on here was size, so it does successfully execute this code and call size, and I can verify that it did my version. But what if inside here you call one of these other things, you call isdir or something else, and you didn't implement it, then it crashes. So, but that made me happy, because it validated my understanding of like how much magic is happening here, and the answer is like not a lot of, not magic, which is good. We don't like magic. So, parting words, cleanest code is a code not written. For everything else, there's Go. And resources. I think the guy that asked me about concurrency left, but I've read this book, and I've been reading this book, and I actually think that if you really want to get right into Go routines, the first running example in this book is both excellent and also practical, something you might actually write in production code. But I highly recommend both of these books. Everything else on here is self-explanatory except this. Everybody Go here. This, if you think that the gopher is too goofy and happy and you want to punch him in the face, this Renee French that designed the gopher, you will be shocked her actual artwork. It's so, these are her words, gritty and creepy. And it is gritty and creepy, but it's amazing. So go check out her other stuff that's not a grinning, toothy gopher. And that's it.